All right, good morning, Algebra 1. All right, so just a reminder, your quiz is on Thursday. So the quiz is Thursday. The next time I see you, it'll be 10 questions, multiple choice, and that'll be on September 10th, Thursday, September 10th. All right, so we're going to go over everything we've talked about so far in this class. You've had 3 guided note packets. So packet 1, seeing structure and expressions. So the main things we did here were identifying parts of an expression and then simplifying expressions. So these are the 2 main things we did. So let's go ahead and start off with identifying parts of an expression. All right, so we talked about terms, a number or variable, or a number multiplied by a variable, separated by the plus or minus signs. So here's our example up here. How many terms do we have? So it looks like we have 1, 2, 3, 4. 4 terms total. You'll notice that I circled the subtraction signs with the term that's right after it. That's because the subtraction sign makes it a negative. All right, so our first term is 6x squared. That's all together, one term. Remember, these are separated by plus or minus signs. My second term is negative y squared. So that subtraction sign becomes a negative, negative y squared. My third term is 3x. I don't need to put the plus sign because I know it's positive, positive 3x. And then the last one is a negative 10. So these are my 4 terms if I had to list them out. All right. Next up. Variables, an unknown value represented by a letter. Alright, so let's see how many letters we actually have in this expression. We have an x, a y, and an x. So we have 2 variables in this expression, x and y, because those are the only letters I see. Alright, coefficients. A number being multiplied by a variable. So it's basically the number in front of the variable. Alright, so let's look here. The coefficient of the x squared term is 6. It's the number in front of x squared. Alright, the number in front of the y squared is negative 1. I know you don't see the 1, but it's understood to be there, so negative 1 is that coefficient. The coefficient in front of this x is 3. Alright, what about negative 10? Negative 10 is not a coefficient because there's no variable attached to it. It doesn't have any letter. Okay, so what is it then if it's not a coefficient? That brings me to my last vocabulary term. It's a constant. A number by itself in the expression, a constant. A number by itself. All right, I want you to go ahead and do example 1 on your own, and then we will go over it before the quiz. So pause the video and try example 1. All right, simplifying expressions. So we learned 2 things. First, you use distributive property. Multiply the number on the outside of the parentheses by every term on the inside, right? So if I have 5 times x plus 1, I'm going to distribute that 5. 5 times x is 5x. 5 times 1 is 5. There's a plus in between it because that's a positive 1. That's distributive property. Combining like terms. You're going to identify any terms with the same variable raised to the same exponent. Add or subtract the coefficients. (7) x squared minus 3x squared. Those are like terms because we have the same letter raised to the same power. If this were just 3x, I wouldn't be able to combine them. They're not like terms. But since they are like terms, I just add or subtract the coefficients based on the sign. So 7 minus 3 is going to give me 4x squared. All right, so that's distributive property and combining like terms. Let's go ahead and try example 2 together. All right, so example 2. First thing we need to do is distribute. We got to get rid of the parentheses because parentheses comes first in PIMDAs. So looking at this, it looks like my 3 is on the outside. So I'm going to distribute 3 to every term on the inside. So 3 times x will give me 3x, and 3 times square root of 2 will give me 3 square root 2. Pretty easy, right? There's a plus sign in between them because the square root of 2 is positive, and then this last term on the outside, you just bring it down. So I've got 3x plus 3 square root of 2 minus 2x. So I distributed my 3. All right, now let's identify like terms. So same variable raised to the same exponent. I've got 3x and I've got negative 2x. Remember that subtraction sign stays with whatever term it's in front of. All right, I know these are like terms because they're the same letter and they're raised to the same power. All right, I know you're telling me I don't see any exponent. When you don't see an exponent, you can assume it's a 1. So these both are the same letter x and the same exponent of 1. So 3 minus 2 is going to give me 1x, and then I'm just going to bring my constant down. Now I don't need to write the 1. The 1 is understood. So my final answer is going to be x plus 3 square root of 2. I don't have any other terms that I can combine with 3 square root of 2. It would have to have the same radicand, square root of 2. All right, let's go ahead and do example 3 together as well. All right, tell me, what do you think the number on the outside of the parentheses that we're distributing is? All right, I hope you said negative 1. So there's a negative sign, and I don't see any number, so it's understood to be a 1. So I'm just going to distribute the negative 1. So negative 1 times y squared is going to give me negative y squared. Negative 1 times positive 5 is going to give me a negative 5. And then I'm just going to bring my last term down, the term that was on the outside of the parentheses. I do not distribute the negative 1 over there. It's not in the parentheses. All right, let's identify all of our like terms. There's no other y squareds, but I have 2 constants, right? 2 numbers by itself. Numbers by itself are always like terms, and they can always be combined. So, negative 5 plus 9 is going to give me a positive 4. So here is my final answer, negative y squared plus 4. I want you to go ahead and do example 4 on your own, and we'll go over that on Friday. All right, so that was it for packet 1 that we went over. Packet 2, rational and irrational numbers. All right, so rational numbers are any real number that can be written as a fraction. Any real number that can be written as a fraction. So 3 over 2, 0.1, because I can write that as a fraction, that's 1 over 10. 3, 8, anything like that. That's all rational. All right, rational numbers also include these separate categories that we went over, right? Natural numbers are rational, whole numbers are rational, and integers are rational. So natural numbers are counting numbers starting at 1. Whole numbers are counting numbers, but they start at 0. And integers are counting numbers that can be negative, positive, or 0. So let's say negative 3, negative 2, negative 1, 0, 1, 2, 3. All right. Irrational numbers, a decimal that does not end and does not repeat. We'll know that it doesn't end because they've got little dots after it, and we'll know that it doesn't repeat because we won't see any repeating pattern. You'll also know that non-perfect squares are irrational numbers. So here's some examples. There's no repeating pattern, and I've got the dot, 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 which means it doesn't end. Square root of 13 is a non-perfect square, so that makes it irrational. And remember, pi is always an irrational number because pi is a decimal that doesn't end and doesn't repeat. Pi goes on forever. All right, let's try example 5 together. Classify the following numbers using all possible classifications that apply. So we need to use all of the terms that apply. All right, so looking at this, 1 over 2. Well, it's a fraction, so I automatically know it's rational. If it's rational, it can be any of these 3 categories if it meets the requirements. So let's see, is it a natural number? No, it's not a counting number. Is it a whole number? No, it's not a counting number starting at 0. And is it an integer? No, because integers are whole numbers, but they're negative or positive. So it looks like this one is rational only. All right, next up, pi. What do you think about that? All right, I hope you said irrational, because it's a decimal that doesn't end and doesn't repeat. It's irrational only because irrational numbers don't have any other categories, right? All of these are rational numbers, but irrational numbers, that's the only category you can apply to it. All right, looking at this is a decimal, and it looks like it goes on forever because that's what this line at the top means, but it also means that it goes on forever in a pattern. So this is like 0.929292 ... So that means it repeats. If it repeats, it's not irrational. That makes it rational. All right, let's see if it falls into any of the other categories. Natural, whole, or integer. No, decimals and fractions don't fall into any of these 3 categories, so it looks like this is going to be rational only. All right, 0 is not a decimal, and it's not a non-perfect square, so it must be rational. What else can it fit into? Is it a natural number, a counting number starting at 1? No. Is it a whole number? Remember, whole numbers include 0, so yes, it is a whole number. If it's a whole number, it's also an integer, right? Because integers include negative, positive, and 0. So this fits 3 categories: rational, whole, and integer. All right, I want you to try example 6 on your own, and we'll go over it for review on Friday. And we'll also fill these in on Friday as well. So do your best to look over your notes and fill in these blanks, and we'll cover all this on Friday before the quiz. All right, last up, packet 3, radical operations. All right, so here's what we did with radicals or square roots. We simplified them, we multiplied them, and we added and subtracted. This should say radicals. Sorry. Your teacher was sleepy making this. All right, simplifying radicals. All right, so number 1, we're going to create a factor tree for the number under the radicand. All right, so my number under the radicand is 48. And I'm going to bring the 2 out there with it. All right, so I'm going to create a factor tree for the radicand, which means I'm going to try and identify 2 numbers that multiply to get 48. Try to identify perfect square factors because they have a pair of the same number, which will save you time and effort. Okay, if it saves me time and effort, I'm all about it. So let me go ahead and write up the perfect squares up here. One times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So let's see if I can get any of these factors into 48. Well, it's definitely got to be smaller than 48, right? 49 won't go into 48, so let's see if 36 will. Nope. Let's try 25. Nope. Let's try 16. Oh, 16 will work. Let's do that. 16. Alright, so the whole point of picking 16 is so that I can identify a pair as quickly as possible. I know that since 16 is a perfect square, it must have a pair that's identical as factors, 4 times 4. And then I'm done, right? Because I've got a pair, and my only other number over here is a prime number. So I'm ready to break it down. So I'm going to bring the 4's outside as a single 4. Remember, I've already got a 2 on the outside, right? So I've got 2 times 4, and the only other thing left underneath the radical is a 3. Two times 4 is 8. So here's my simplified number before we even handle the variables. Ooh, looks like I already did step 2. Circle the pairs and box the remaining single factor. Bring the circled pairs outside as 1. So I already did that, so it looks like now I've got 8 square root 3 as my simplified number, and I'm just going to rewrite everything else. We're going to handle that in a second. Alright, multiply all the numbers on the outside of the radical. We did that. 2 times 4 is 8. And multiply all the numbers on the inside. We didn't need to do that because the only number on the inside was 3. Alright, once you've simplified the number of the radical, which we have, identify any exponents above the variables and rewrite them if possible. Alright, so let me go ahead and put my 8 square root 3, x to the 10th, y to the 5th, and z. Alright, so we need to rewrite any exponents that are not even. 10 is even because I can divide it by 2, but 5 is not. So I need to subtract 1 from that exponent and rewrite it. So let's rewrite it like this. Five minus 1 is 4. And then I'm just going to leave that y underneath it, and I'm going to leave the z as a 1. Right? I cannot subtract 1 from 1 because that'll give me 0. That won't work. So I need to just leave everything like this. Alright, now that I've rewritten it, 3x to the 10th, y to the 4th, y to the 1st, z to the 1st. I'm going to pull the variables with the even exponents, which is this one and this one, outside, dividing the exponent by 2. Alright, 8's already out here. When I divide 10 by 2, I'm going to get 5. So on the outside is x to the 5th. When I divide 4 by 2, I'm going to get 2. And the only things left inside the radical are the 3, the y to the 1st, and the z to the 1st. Notice I don't need to write 1 as an exponent. It's understood. It's not a pair, so it does not get to come out. Alright, there's my simplified expression. Alright, I want you to go ahead and try example 7 and example 8 on your own, and then we will review it before the quiz. Alright, multiplying radicals. So the first thing that you do here is multiply the outside numbers. After that, you can multiply the inside numbers, and then you just simplify what you have. So let me go ahead and do number 9 for you. The two outside numbers are negative 3 and 5. So when I multiply the coefficients, I'm going to end up getting negative 15. When I multiply the two inside numbers, 2 times 10, I get 20. Alright, so let's go ahead and break this down. I want to check first and see if I have any perfect square factors. So I'm going to have to start with the first perfect square that's not 20, that's lower than 20. So I'll start with 16 and go down. I'll try 16, 9, 4, and 1. Remember, this saves us work. Okay, that doesn't work. So let's try 9. That doesn't work. Let's try 4. Ah, perfect. 4 works. So remember with 4 we have 2 and 2, so I can stop there. And I'm going to put a box around the 5 because 5 is a prime number, but there's no pair to go with it. So I have negative 15 on the outside. I'm going to pull this pair of 2's on the outside, but they're going to come out as 1, 2. And I'm going to leave the 5 on the inside. So the last thing I need to do Alright, it's my final simplified answer. Alright, I want you to try example 10 on your own. We'll review it before the quiz. And then last up, adding and subtracting radicals. Alright, so you're going to simplify all radicals in the expression. Once you're done simplifying anything that needs to be simplified, identify terms with the same number underneath the radical, same radicands. And then you're going to combine the radicands by adding and subtracting the coefficients of the like radicands only. Those are the only ones that you can combine. Alright, so let's go ahead and do number 11. So we got to simplify everything. This looks like it can't be simplified any further. This one as well. So the only one that we need to simplify, and I'm going to do it way out here so we don't get it mixed up in our other calculations, is negative 5 square root 12. Alright, some factors of 12, 3 and 4. 4 breaks down to 2 and 2. Alright, so that means I'm going to bring 1, 2 on the outside, and I'm going to leave a 3 on the inside. Remember, my negative 5 was already out there. So negative 5 times 2 is negative 10. And that's my simplified version. Alright, so what I'm going to do is I'm going to take this and plug it in for what we had up here. So square root of 3 plus 8 square root of 3 minus 10 square root of 3, right? We simplified it to 10 square root of 3. And now look, every single one of my radicals has the same radicand, so that means I can add them all together. Alright, I don't see anything in front of the first one, but I know that's a 1 when I can't see it. So I'm just going to add these coefficients. 1 plus 8 minus 10. And I end up getting a negative 1 square root 3. So this is equal to negative 1 square root 3. Remember, I don't need to write the 1. It's understood. So I can just write this as a negative square root 3. Alright, go ahead and try example 12, and we will review that on Friday before the quiz.